Now in this lecture we are going to introduce the concept of the derivative of a function. You have learnt already about the limit of a function at a point as well as the continuity of a function at a point. If the limit exists, we cannot say the function is going to be continuous at the point. But however, if a function is continuous at the point, it is necessary the limit should exist at that point. So continuity is one stage above the limit. Likewise, if a function is continuous at a point, you cannot say that it is differentiable at the point. However, if it is differentiable at a point, it is necessary that the function should be continuous at the point and limit should exist at the point. So now we come to the definition of the derivative of function at a point. In order to define the derivative of function, it is essential to assume that the function is a continuous function. Now, suppose f of x is a continuous function. Suppose f of x is a continuous function. The derivative of the function is going to be defined as follows. So the derivative of the function is defined by f dash x equals limit h tending to 0 of f of x plus h minus f of x divided by h. This is called the derivative of the function f of x. So we can introduce the concept the derivative of the function f of x is now defined in this form. Now the derivative is also called the differential coefficient. If we denote y equal to f of x, then f dash x is also denoted by dy by dx. F dash x is also denoted by dy by dx. Sometimes the notations for the derivative of function is y dash is nothing but f dash x, or y1 equals f dash x. These are all some standard notations for the derivative of a function. Having defined the derivative of the function, now comes the question, what is the meaning of the derivative of a function? We have geometrical meaning and physical meaning. We are going to now introduce the geometrical meaning of dy by dx, the physical meaning of dy by dx. First, let us now come to the geometrical meaning. When you consider a continuous function y is equal to f of x, we know very well that this is the graph of some function. If y equal to f of x is a function which is continuous, it is possible to draw the graph of the function. When we draw the graph of the function, we are now interested what is the slope of the tangent at a point. Now this dy by dx represents the slope of the tangent at a point on the curve. Suppose a function y is equal to f of x is now represented by this curve. Consider any point x comma y on the curve. Draw the tangent at that point. Now the slope of the tangent is denoted by dy by dx. Therefore, we say dy by dx represents the slope of the tangent dy by dx represents the slope of the tangent at x comma y on the curve. Y is equal to f of x. It is also the gradient of the curve is also equal to the gradient of the curve at x comma y. So slope and gradient are one and the same. To emphasize, we say that the slope of the tangent at the point x comma y, and we simply say the gradient of the curve at the point x comma y. This is the geometrical meaning of dy by dx. What is the physical meaning of dy by dx? See, dy by dx represents the rate of change of y dy by dx represent the rate of change of y with respect to x. Rate of change of y with respect to x. Suppose y is the distance traveled by a particle moving along a curve, and x represents the time. Then dy by dx is the velocity. Dy by dx is equal to velocity at time x. Sometimes we write dx by dt. X is the distance traveled and t is the time. Dx by dt represent the velocity at time t. Now, if you go into the second derivative, we are going to see in differentiation the meaning of the second derivative. That means the first derivative is a continuous function. You find out the derivative of the first derivative, it is called the second derivative. It is denoted by d square y by dx square. This represents the acceleration of the point at time x. We now call t instead of that at the time x. So there are several meanings for dy by dx. One is the slope, the other is the rate of change with respect to the variable x. If x represents time, dy by dx represents the velocity, and the second derivative represents the acceleration. Now, having seen the meaning of dy by dx, both geometrical as well as physical, now the graph of several curves are represented by equations, rather algebraical equation. So we are now interested to know how to find out the derivative of some standard function. Now let us consider a continuous function y is equal to f of x or f of x equal to x to the power of n. N is an irrational number, say. Now what is f of x plus h? This is nothing but x plus h whole to the power of n. Now f of x plus h minus f of x divided by h is now given by x plus h whole to the power of n minus x to the power of n divided by h. I can rewrite in the form x plus h whole to the power of n minus x to the power of n divided by x plus h minus x. What is the definition for the derivative of the function? F dash x is nothing but limit h tending to 0 of f of x plus h minus f of x divided by h. This is same as limit h tending to 0 is same as x plus h tending to x of f of x plus h minus f of x divided by h. This can now be written as x plus h whole to the power of n minus x to the power of n divided by x plus h minus x. You have already learned under limit this is nothing but n times x power n minus 1. So, the derivative of the function x power n is nx power n minus 1. We can always write this also in the form, we can write in the form d by dx of x to the power of n is nothing but nx power n minus 1. Or sometimes we also write if y is equal to f of x, y is equal to x to the power of n, then we write dy by dx equals nx power n minus 1. There are some standard procedure of writing down the derivative of a function. Now, having seen the derivative of the function y equal to f of x as n times x power n minus 1, it is possible proceeding on the same lines as we use in the derivative of x power n, we can write down the derivative of so many other functions. I am now going to list only the derivative of various functions, and you try yourself how to arrive the results for the derivative of those functions proceeding exactly on the same line. You have learned already several standard results under the limits of various functions, namely algebraical function, exponential functions, logarithmic functions, and so on.